So yeah, now we're recording. Share, blank whiteboard, share application, entire screen. Share. Okay, who wants to do a problem? Somebody? If you guys really don't want to, I can do it, but you'll learn better if you're up here writing it. You don't have to. We're in college. I'll let you make your own decisions. Okay. Let me find one. Okay, I'll give you a choice. Do you want to do another one like that, or do you want to derive the Henderson-Hasselbalch equation? Which I'm fairly sure you wanted to do on the test, but I didn't write the test, so I don't know.
Is it necessary to do the deriving, or should we just go to the next?
I mean, it's cool if you like math, but I never had to do it on an exam.
Can we use it? Is it
What is that equation?
The Henderson-Hasselbalch?
That would be given, correct?
I mean, you should know it. You guys know the Henderson-Hasselbalch?
pH equals pK plus log of
A minus over HA. Yeah. Can you write it for me? So just so everybody has it in their notes. Yeah, so if you guys don't know this one, this is another thing to super flashcard and make sure you know it inside and out. It's fine. We know what you mean. You guys are so careful with like your smart board writing, and I'm kind of just like throwing the pen at the board vaguely. Yeah, good. So do you know what A minus and HA stand for, typically?
So that's normally when the acid is then going to plus 1 is in equilibrium.
Yeah, I remember going over that.
Technically H3O plus, because then it's not balanced. Yeah, so in short, HA is a generic acid and A is just a generic base. So I think I didn't really look at your sapling, but I think there's a problem or a couple problems where it had you like just do it with H plus and A and all that stuff, just like generic stuff. So don't get freaked out by that. Just treat it like X, or you can pretend like it's HCl or something. But yeah, that just means the base and the acid is conjugate base. Okay. So this one's kind of similar to the last problem. You're going to see everything with like acetate in it. What mass of sodium acetate would be needed in 300 milliliters of 0.25 molar acetic acid? To make a pH of 5.09.
Acetic is
COH, yeah, good. pH of 5.09. So you have a certain volume and concentration of acetic acid, and we have the pH. Now we want to dump in a certain amount of solid sodium acetate to get that pH. Make sense? Do you know how you would start that?
So this is working backwards from what we did last time, basically.
Yeah, it's pretty much working backwards.
So we have the volume and molarity, so we can get moles of that.
Mm-hmm.
And then we can use the ice table for this equation, and you'll have the X value from converting with the pH.
Mm-hmm. You could do that. Let me give you one more clue. They give you the Ka. So the Ka is 1.8 times 10 to the negative fifth.
So you have pH, you'll have Ka. And then if you write out the equation, you can figure out these.
But then you'll have two unknowns, right? So you have concentration and concentration.
If you get the ratio of it, can you do something like that?
Yeah, but you'd have to solve for the ratio. Me mentioning the Henderson-Hasselbalch equation wasn't a clue that you need to use it for this problem.
Okay.
That was just like.
Okay, I thought because you said pK.
No, that was a different problem. I just wanted to make sure that you guys know that because that's like fairly fundamental for this course. So I just wanted to make sure that you guys knew that one. But if it's like annoying, you can like cross it out or slide down because you won't need to use that for this problem. Why don't you start with this? Yeah, 1.8 times 10 to the negative fifth. When in doubt, if you guys don't know what to do, write the chemistry first, because I'm confident that you guys can do the math because you go to IIT and you're all engineering majors or whatever, science. So start with the chemistry because that's the hardest part. So chemically, like what's happening here? Write the equation.
Yeah, this one, breaking up.
And if you want, you can exclude water because, because it's a weak acid. Minus, plus, H. Yeah, good. So just from that, from nothing else, if you just knew this, what's something that you can get from that? There's a mathematical quantity / equation that you can write
You mean,
with the
just
reactants
because
and
it's all
products.
one-to-one, you know, the concentration of this is equivalent to that concentration also.
And you can write the Ka equation, right? So Ka equals,
Concentration of that plus, or times that over that.
yeah, write it for me. Okay, so this problem's asking us for grams, right? And if we have the moles, we can convert to grams. And if we have the molarity and the volume, we can get to moles. So I'm not going to do the drug. I'm just going to softball you some stuff because this isn't necessarily an intuitive problem. So we have the concentration of this, right? We know this. So we need these two, right? Because if we find this, we find the concentration of that, we know the volume. So we can find the moles, and then you'll have a periodic table, so you can go from moles to grams, right? And we need grams of sodium acetate. So this is what we're looking for right now. So we need this. What is concentration of H plus? Equals, like, what's like the general math equation for concentration of H plus?
10 to the negative pH.
10 to the negative pH, yeah, good. If you guys don't have that, write that down. Super important, put stars around it. So do we have the pH?
Yes.
Okay. So
It's 10 to the negative 5.
10 to the negative 5.09. And because I had a calculator before, I can tell you that that's 8.1 times 10 to the negative 6.
Do I use the bottom to sum it up?
Oh, is this what you're trying to do?
Yeah.
Yeah. So H plus, the concentration of H plus is 8.1 times 10 to the negative 6.
Negative 6.
Mm-hmm. Molar. So we have pretty much everything from that equation except for one, right? So when you have one unknown in an equation, what do you do?
Plug everything else in. Rearrange.
Yeah, rearrange, plug everything, or plug everything else, rearrange. Yeah, I think so. Did you divide it by acid? Yeah. Okay, and since we have the values, you can plug those in, and I'll tell you that it comes out to 0.56 molar. So there's an equation from Chem 1. If we have the molarity and the volume of one thing, and we need to find the molarity and volume of another thing, what's that equation? M1V1 equals M2V2. Mass. So that's in, we're solving for mass, and that's in molarity. So all we need to do is, rearrange for molarity, and then we'll solve for the mass. What is that? M2 equals M1V1 over V2? Yeah. Yeah. So Yeah, you're on the right track. So the important thing now is just knowing like what actually those variables are. So M2 is molarity of what?
CHCOONA.
Yeah, actually good. So that's what we're solving for. So plug this stuff in.
Volume 1 is not total, correct? Volume 1 is with the space part M1 and V1, right?
I'm looking at it.
Is volume 1. M1 is concentration of CH3CO minus.
So your M2 and your V2 are going to be for CH3CO minus and the total. And you divide that just by
6.25 times 300 divided by
0.25 is for, yeah, acetic acid, but we're working with sodium acetate right now. Little lost?
So we're using
That's
this
okay.
one?
Yeah.
0.56.
Oh, yeah, actually. Yeah, good.
6.56. Volume is again in 300.
Or 0.3. If you want to just make it easier on yourself. Yeah, and that's just going to be over 1, right? Just over 1 liter.
1 from where?
Just because we're working with like unknown molarity, and so we don't know how many moles. Yeah, it's just going to be over liter, over 1 liter. So from there, that's going to give you moles per liter, right? Or just moles.
Yeah.
Actually, no, that's just going to give you molarity. So then from there, you need to moles per liter. I want to make sure I'm not throwing you off because my notes are funky here.
If you have molarity.
Okay. So one thing that we can do here is this will be over 1, but the 1 actually isn't what I said for this before. What is 0.56 molar? That's 0.56 somethings per 1 liter, right? That's 0.56 moles per every 1 liter.
Yeah.
So this is actually going to be in moles, not molarity. So we're going to have moles of sodium acetate here.
Okay.
And so since we have moles of sodium acetate in the answer, then we just multiply by the molar mass, right? Which will be 82 something. 82.0. Yeah, and it comes out to 14 grams. Because we have 2 sig figs at 1 part. Okay, thank you. So I know this one's kind of funky and not necessarily what you've been expecting with the other ones, so let's run through it again. So we have our acetic acid solution, right? And we have sorry. We have our acetic acid solution, we have the pH, and we want to know how much other stuff to put in it. So from there, we write out our Ka, and we write out the equation. We can solve for everything except the one unknown, which is the concentration of acetate. So then the next part is finding the concentration of acetate, and then converting that from molarity into grams. So that's molarity to moles to grams.
So in this step, it's
For 1 liter, yeah. It's the same thing as moles for 1 liter. Right? That's kind of like, well, the assumption is kind of like when you were doing percent mass, And it's like, okay, well, if it's 90% carbon, then you just say, okay, well, it's the same as 90 grams out of 100 grams, right? So we'll assume it's 100 grams of solution. That's kind of what we're doing here. We're saying, well, we have 0.56 molar. So we'll assume that's 0.56 moles in 1 liter.
So 300 in the beginning is specific to acetic acid. It's not the total of it.
No.
I used the Henderson-Hasselbalch equation and I got the same answer.
Did you?
Yeah,
Was it faster?
way faster.
Okay. Then next time you can use the Henderson-Hasselbalch equation.
Yeah, you just have to know the rules of logs and know that you have to like subtract your dividing.
Yeah.
That makes sense.
Yeah, I feel like that's less intuitive unless you're like a mathy person. So if that makes more
I'm
sense.
not a math person, it's just.
Okay. Well, I mean, that just goes to show you can solve it many ways. This way is easier for me because I know the chemistry better than I know the math. So that works for me. Makes sense to you?
Yeah, if you're using the equation, then which part are you solving for?
You still have to solve for concentration of acetate. But what she does is she breaks it up. So pKa plus log of concentration of A minus log of concentration of HA, right? Yeah.
And then you're solving for concentration of HA.
Yeah. So then you're, so I
You
guess,
get negative the concentration A minus from the pH.
I mean, if you want, I can show you and write it down, or you can look at my paper.
if you want to do it, you can.
It's really. And I was like really surprised that it came out to the same answer.
No, good for you. That's awesome. Especially because everybody seems to run out of time on chemistry exams specifically.
Okay, so just really quick, I also remember the pKa of 1.8 times 7 negative 5 is 4.74. And then 300 milliliters of 0.250 molar ends up being a concentration of 0.075 for acetic acid. And then you have your X, which is the acetate ion,
Yeah, the concentration.
the concentration of the
So-
acetate ion.
One thing yeah. And then for the outside, try to use parentheses because brackets means something really specific. in chemistry.
Yeah,
I hate
It's
being
a bad
nitpicky
habit.
about notation,
no,
but
it's a bad habit.
sometimes it is good
I'm
to be
aware of
smart
it.
on that stuff.
Wait, so
And I'm just trying to go through it too fast.
where did you get the pKa?
This is a 1.8 times 10 to the negative fifth, negative log of that.
Remember, if you want to go from something to the P of that, if you want to go from Ka to the pKa, take the negative log of it.
So none of those numbers were given, which means we have to have that memorized.
Yeah, or
So
you can
then-
calculate it. You'd have to have the equation memorized.
Subtract 4.74.
One thing one of my professors did was like, she gave us a thing, and it was like all these different things, and you have to convert it to P, and one of it was like, find P of dog. So you take the negative log of dog. Yeah, I know it's goofy, but now I never forget. Like, if you want to find pKa, it's negative log of K. If you want to find pH, it's negative log of concentration of H.
Do you know how we got that? Everybody?
Yeah.
How
did you get the 0.075?
Oh yeah, that was 300 milliliters of times 0.250 milliliters of acetic acid. Should be up there. No?
To get the moles?
This is molarity. Oh, it is moles. No.
That's moles.
Yeah, but it worked out for the, because what ends up happening is you get moles up here. So maybe I did it wrong, but I don't know. I got moles up here and then moles down here, and then they cancel each other out. So you just get,
Something unitless.
yeah, it's basically uniform.
I think it's okay, like, as long as the quantity is unitless. I don't think it's an issue.
Yeah, so then I added this over here. This ends up being a negative number. So this ends up being a negative number.
Because it's all linear, right? Like, moles to molarity is just linear, so as long as,
Yeah, so my answer is in moles. That is a very good point. And then 10 to the negative 7.775, 10 to the x, that's that. This ends up being 0.168 moles. And that is very important that you know that it is moles, because then you go times 82.04 equals
that's the molar mass of sodium acetate.
14, because we're in 2 sig figs. And I didn't even use the M1 B1 equals M2 B2 because I did totally forgot about that.
Yeah, that works too. Good job. I didn't even solve it that way. Are you guys clear on where like all the numbers came from? Like she calculated a bunch of them, and then 82.04 is the molar mass of sodium acetate. So if that was easy for you, do it like that. That's great.
Yeah, because Henderson stuff back is like really easy to remember.
Yeah, more power to you. Okay, we have time for one more problem. Who wants to do it? Somebody? I'll do it if you want, but you'll remember it better if you do it. No? Okay, that's fine. Let's do. What would be a good problem? Yeah, let's derive the Henderson mass equation just because I did it, and I feel like I wasted my time if I don't do it now. Okay, so we have our generic acid equation, right? Right? It's our generic acid dissociation. So we can write the Ka just HA, right? Yeah, just HA. So this breaks up into H3O plus times concentration A minus over concentration of HA. So then the negative log of Ka, if you take the negative log of everything, is equal to the negative log of concentration of H3O plus the negative log of A minus over HA. So we just took the negative log of everything, and then once you do that, you get pKa is equal to pH minus log of A minus over HA. So then you add this to the other side, you get pH equals pKa plus log A minus over. Okay, so I guess there is kind of a point in doing this. You gotta have that down, and it's important to remember the relation between like taking the negative log of something and getting the p, because like you might get an equation, or you might get a problem where they give you the pKa, but they don't give you the Ka, and you need the Ka to solve it. So you have to know how to go between those. You guys know how to undo the log? Yeah, 10 to that. Good to go. You don't really need to know the derivation, but I feel like it's important to go through it just so you can see like, this is how they use logs and all that stuff. I don't know. Makes sense. For the last few minutes, what are your questions? Like, what are you guys thinking about? Okay, here, I'll do this.